Students, last class we have discussed about the architecture of 8051. Yes, still 61 students are there. Esma, we'll start today. Angeline, register number 8. Will you tell about the registers in 8051, ma? Angeline, is it my voice is audible, ma? Students? Yeah, Angeline.
Sorry, ma'am.
Yeah, tell me. Yesterday we have discussed about the architecture. Tell me some register in 8051, ma. Students, while you are attending the class, kindly take the notes. Because even we will share the notes, we will share the PPT, but it's for your remembrance to take the key points. Please kindly take the notes. Is clear? Anyone tell some registers in 8051, ma?
Accumulator,
Very
start,
good. Accumulator,
start
Data
pointer,
pointer,
interrupt, program
counter,
counter, be registered.
program counter,
DPTR,
DPTR. Very good. DPTR. Okay. 8051 is 8-bit. 8-bit. It can handle 8-bit data. Okay. And the address bus length will be 16-bit. Okay.
16.
So first class we have seen about comparison of microprocessor and microcontroller. The next class we have taken the architecture, but in architecture we have to discuss about the registers. Hardware IO pins, that is nothing but pin diagram we already discussed. So today we try to concentrate on memory and register. Can you understand? So today our scope of the lecture is about memory and the registers. So I think I will directly move on to the slide. Nearly 81 students. Yesterday Sundar Singh sir clearly state that how much time you were be in the class. If you are leaving or you are rejoining, everything will be generated as a report. So your attendance will be taken from that. Even I will take the attendance intermediately for the cross verification. Okay, so you people please kindly attentive, and your time duration is noted. So first 2 hours today we have principles of embedded system, the next hour followed by your power system. So both the hour you have you're attending now, nearly your time duration should be 120 minutes. So you have to be in the lecture for 120 minutes. Are you clear? Because we were taking the classes in online mode, you're supposed to listen the class, because some concepts were new for you. So that's why we were putting some efforts for you to understand. Because in theory mode we can have a face to face interaction, but here it's not like that. So you people have to be answer my questions, then only I have a hope on that you people were listening. I think I'm getting good response from you people. Thank you very much. Yesterday and today also I have noticed some of them were saying DPTR. Even I have not elaborately explained, but you people were saying thank you. Please listen it. It's a very easy subject, not a tough one. So if you listen from the class, I think you can carry out the knowledge while you're preparing. It will be very easy for you. So that's why we request you to people to listen. Is clear, ma? Okay. Now I'll directly go on to the directly we'll go on to the architecture. Okay. Yesterday we have seen this architecture. Okay. We have seen about 4 ports, memory units, oscillator circuit, and synchronized with the timing and control. The heart of the system ALU, interrupt and timer blocks, and the program counter. So this and all. So wherever these are all bus, wherever it represents, all are bidirectional only. So you can see that all the buses are bidirectional. Sometime they will mention 8. 8 means the data bus length will be 8 and address bus length will be 16. So this portion is mainly for address, because program counter means what? It will always carry the next address of the instruction. So it will be 16 bit. So that's why we have represented as a 16. Can you understand? And here VCC, supply. Supply is 5 volt and then ground. Now, this is a system clock I mentioned to generate the clock pulse. And the frequency is 12 megahertz. So I told you time is inversely proportional to frequency. So frequency increases, time decreases. So the speed of the processor is also get increases. So this is the proportional with frequency, time and speed. Okay, and this is the registers we have discussed. So the registers we will see in detail. Before going into the register, um, we will see about, okay, first we will see the register, then we go for the memory memory organization in 8051. Okay, because I think the registers already you have a well known, some of the registers name you have already learned. So here we will see what are the registers. What is register? Anyone can explain what is register? What is register, ma? What the register will do?
Store the data.
Yeah, very good. Not only store the data, as well as it will do all computing functions. It will store the data, and the data will be moved from memory to port, as well as it will receive the data from port to memory. So it will act as a bidirectional to receive as well as send the data. So the register is very, very important in a processor. When I am writing any program, my data will be handled only by the registers. So the register is very, very important. So here we are going to discuss about the register one by one. Okay, now accumulator. What is accumulator? Accumulator is a primary register for all processor and controller. Here also when you take, here also the accumulator is a very important register and a primary register. So if I want to do any arithmetical and logical operation, my result will be stored in the accumulator. Yeah, Vignesh, what is your question, ma? Vignesh have raised the hand. Vignesh, you are checking whether it is working or not. Okay. So if you have any doubt, you can, I think this is the mode very easily. You can unmute your audio and you can ask, or you can raise your hands. Okay. Now, the accumulator is a primary register. So if I want to store any arithmetic and if you want to do any arithmetic and logical operation, my results will be stored in accumulator. Okay. But you have to know what is the length of the microcontroller? 8 bit. So the accumulator length is also 8 bit. The other register length will be vary, but accumulator length doesn't vary. So if my processor is 8 bit, means my accumulator is length also 8 bit. Okay, you have seen here accumulator 0, you all know D0, D1, D2, D3, D4, D5, D6, D7. So this is our LSB. Okay, least significant bit and most significant bit. So here you see that EACC dot do means that is second bit of the accumulator. So I can do all bitwise operation also here. I already told you that bit handling instructions also there. Instructions and all you will study in the second unit only. Now you will study only the architecture and what are the component inside that processor and how it is working. That is only our the first unit objective. So you have to learn about microcontroller and the architecture and the hardware parts of the microcontroller. Okay, the next instruction register is B register. B register is nothing but a register, is a general purpose register only. Mainly in microprocessor we have in 8085 we don't have a multiplication and division. Am I correct? How will you do multiplication and division in 8085, ma? Anyone?
Multiplication means by addition,
Yeah, very good.
and division, addition and subtraction both will come.
Division means repeated subtraction we will do. Can you understand?
Yes,
Multiplication,
ma'am.
repeated addition. Division, repeated subtraction. But here we have a mul div, very simple. So multiplication means mul AB means A into B. Div means A by B. Okay, so accumulator will hold the quotient value and B will hold the remainder value. Similarly, A into B, na, lower order byte will be stored in B, higher order byte will be stored in A. So obviously here we have a B register to perform multiplication and division. Can you understand? And they give one word, bit addressable. I will explain you. All the register we have address. When you take one apartment, in apartment they will give the name G7, G8, F1, F2, depending upon the block. So similarly here also, that is one of the main difference between the microprocessor and controller. Here all register we have a address. So through the address also we can access the register. But that facility is not available in the microprocessor. Okay, we will see while we are discussing about the memory organization. The next part, today we are going to see only about registers as well as the memory. Okay, so we will see what is bit addressable in the memory part. Okay, the next one is program status word, PSW. It's one of the important 2 mark. Most of the time they ask you to explain program PSW, explain the PSW of 8051 or draw the PSW of 8051, whatever may be. PSW is a program status word. What is the program status word? Anyone can tell? What is program status word, ma? Program status word. Yeah, Kotishwaran,
Ma'am,
Harshavardhan.
it's like a
Sorry.
flag, ma'am.
Yeah, tell me.
Flag, ma'am. Register.
Flag register. Actually, yeah. Whatever the accumulator content, depending upon the accumulator content, the flag register will on and off. That will be reflected in the program status word. Okay, so already we have studied about the flags. Here, what are the flags? Here you see, it's a 8-bit. This is also depends upon the length of the accumulator. If accumulator is 8-bit, means my PSW is also 8-bit. Okay, now you have seen this. This is my PSW. You have to see this here. First I will tell about the flags. Okay, we have 4 flags are there: carry flag, auxiliary carry flag, user defined flag. That is, this is where we will not use oftenly. This is, and overflow flag, parity flag. So carry, auxiliary carry, overflow and parity, it's a user defined flag. We will see why this is used in timer and control only. We will use this user defined flag, but normally this is, I think, new for you. Carry, auxiliary carry, parity, overflow. We will see one by one what it is. Okay, so first we will see about carry flag. You all know what is carry flag, ma? When my data can handle only 8-bit now, if more than 8-bit, that is the 9th bit comes, means automatically my carry flag will set. That is overflow. Can you understand? So beyond D7-bit, I'm having one more bit now. That then at that time the carry flag will set. So I told you here we have option set B C. What is this? Set B. CLRC. Set means set the carry bit. Set clear the carry bit. So I have a bit handling instruction. So very simple instruction. I can not only for bits, it do for the carry flag also. Then auxiliary carry flag. What is auxiliary carry flag means? For example, I will go to the previous slide. You all know what is nibble, ma? What is nibble?
4-bit.
Very good, 4-bit. So for example, 8-bit here, D0, D1, D2, D3. So beyond my D3, I am having one carry bit. That is move on to D4-bit. Automatically my auxiliary carry file set. So that is carry is generated in D3 and it is moved to D4-bit, the auxiliary carry. Can you understand? D7 is carry bit, and when the auxiliary carry will set, so it will be, actually in programming we who don't have access to write the program set like auxiliary carry, but it will be a inbuilt flag because it is inside the accumulator. When the carry is set, when carry is generated in D3-bit, it move on to D4-bit, auxiliary carry will set. Okay, then parity. Parity means we all know while I'm sending my data or receiving my data, we always check with number of ones. So odd number of one is set means my parity will 1. You can see that if we are accumulator, A register is also nothing but accumulator. If accumulator contains odd number of ones, the parity bit will 1. If accumulator had even number of 1, my parity bit will 0. For example, if I am taking the value 80, 80 means what ma? 1 0 0 0 0 0 0. So here how many ones are there? Only one ones. Okay, one ones means that this is a odd parity. Okay, so depending upon that, for example, I am keeping 0f. 0f means what? What is the f value ma? You all know. Here we always represent in which code ma? Microprocessor we will always represent in which code? Very good, hexadecimal code, because here we are using assembler. In the assembler, the hexa code will be converted into machine level code, so we always represent in hexa code. That is also will be same as a microprocessor, it will not be changed. So 0f means what? How many ones will be there? 4 ones will be there. So even number of 1. Very good. The next one is overflow flag. What is mean by overflow flag? Actually, the point I had given, carry flag is used for unsigned arithmetic and overflow is used to detect the error in signed arithmetic. We have to know what is unsigned, what is signed. Okay. Actually, you will ask one question. In binary number, how will you identify unsigned and signed? Anyone have a justification?
Most significant.
Yeah, very good. MSB bit is 1 means we will say it as a sign bit is 1, and that is will be a positive number or negative number depending upon the sign bit we will say. Unsigned arithmetic now, my number will vary from 0 to 256. Okay. For example, 0 to FF means my data will vary from 0 to 256. Signed arithmetic now, my number will vary from minus 128 to plus 128. Can you understand or not? Minus 128 to plus 128. So the D7th bit, they are always allocate for signed number. So we have to give it the priority, the signed bit. So unsigned arithmetic means what? The addition is from 0 to 256. Signed arithmetic means what? Minus 128 to 128. So both the capacities are 256 only. So that is unsigned and signed arithmetic operation. So overflow flag is nothing but carry flag for unsigned arithmetic operation and overflow flag for signed arithmetic operation. Actually, in other processor, we will use as a one bit sign, we will explain it, but here overflow flag we were used to detect the error. So these are the 4 flags. Sometime the question may be like mention the flags in 8051. So you have to mention carry flag, auxiliary carry flag, parity flag, overflow flag. Okay, and next one I told you user defined flag. Okay, so the next, I think we have completed. This bit is one miss not mentioned means they will use for general, actually any extended version, they will include that bit. So you need not to mention anyone in D1. Can you understand or not? So leave the D1 as a blank. Okay, so we have discussed about 5 flags. Then the next bit, it's very important bit in PSW, D3 and D4. You just comment here. What is D3 and D4? This is used to select the register bank. I told you here, bank registers are there. Bank register means each bank have 8 registers. So totally how many registers? 32 register. 8 into 4, 32 register. So my D3 and D4 will use to select which bank has to be selected. We all know if 2 bits means how many combinations will come, ma? 2 bit na how many combination?
4 no.
4. 3 bits na?
8.
8 combination. 4 bits? 16. Okay. So it's all depends on 2 power value. Can you understand? So 2 bits na 0 0 na bank 0 will be selected. 0 1 na bank 1 will be selected. 1 0 na bank 2 will be selected. 1 1 na bank 3 will be selected. So my D3 and D4 bit used to select banks. Can you understand or not? So this is the address of the bank. This we will discuss. I think 8 bit I told you na, 8 registers are there. So 0 0 will be address 0 0 or not register will be there. 01 R1 will be there. 02 R3. 0. So similarly that. So they allocated 8 bytes for each bank. So 00 to 07. Then 08 to 0F. Then 10 to 17. Then 18 to 1F. Can you understand? So you have understand. So PSW is very important to mark. So we have a carry flag, auxiliary carry flag, overflow flag, parity flag, and apart from that we have a user defined flag, and then the two more bits very important used to select the register bank. 00 means which bank will be selected? Bank 0. 01 na bank 1. 10 na bank 2. 11 na bank 3. Okay. The next one is see bank register. I told you na 00 to 07 which bank ma? Bank 0. 08 to 0F 8 bytes register bank 1. Then 10 to 17 register bank 2. 18 to 1F bank 3. Can you understand? So how now this is bank register address. Now we will see what are the bank registers, how they are naming the bank register. R0, R1, R2, R3, R4, R5, R6, R7. So R0 address is what ma? 00. R1 address is 01. R2 address is 02. R3 address is 03. R4 is 04. R5 is 05. R6 is 06. R7 is 07. When you move on to bank 1, same registers will be there. R0 to R7. Okay. But you have to know which register I am selecting now depending upon the 2 bits in PSW. So if my bank, that is bank register I am select 01 means my bank 1 will be selected. 10 means my bank 2 will be selected. 11 means my bank 3 will be selected. So what is the bank registers in R0 to R7 ma? All the bank register contain same R0 to R7, but depending upon the 2 bits of PSW, the particular bank will be selected. Okay. The next one is DPTR. Actually, so far we are discussed about 8-bit address, and this is nothing but a 16-bit address. If I want to access my external memory, I mainly use this data pointer DPTR. So DPTR totally 16 bits are there. In 8085, did you remember the registers ma? 8085, 8085. Anyone please tell? 8085. Yeah, Shanmuga.
Ma'am,
8085, what are the registers? Did you remember? BC, then uh, BC, DE, HL. So I can use B as a separate 8-bit register, C as a separate 8-bit register, or I can combine, I can use 16-bit register. Similarly, DPTR also DPH, DPL. Okay, data pointer lower order, data pointer higher order. So I can use collectively as a 16-bit register, or I can use separately as a 8-bit register. So DPL is for lower order, and DPH is for higher order. I can use combinedly as a DPTR as a 16-bit register. Okay, that is pointer register mainly to access my external data memory. Okay. Then stack pointer. I told you stack pointer here. This stack pointer is mainly used in RAM. Okay. Why it is 8-bit data? Na? RAM capacity is 0 to 256 bytes only. So my data will vary from 00 to FF only. So that's why I'm using 8-bit address. So I will use push and pop. Push will push the data in RAM. Pop will retrieve the data in RAM. So push is pushing into the RAM memory location. Pop is retrieving from the memory. It's like a popcorn, how it is pop out. Similarly, the pop instruction will be work. And the one more thing is it is working on the LIFO principle, last in first out. Okay, that is the concept in stack pointer. Okay. Then program counter. Program counter, what I said, that is one program counter will always hold the next address of the instruction. Whether it is a 1 byte na, it will hold the next address. 2 byte na, after 2 byte. What is byte ma? 1 byte equal to how many bits?
8 bits.
8 bits.
Very good. 2 byte na?
16 bits.
16
Yeah.
bits.
So we will already classify now 1 byte instruction, 2-byte instruction. Similarly, here also we have 1 byte, 2 byte, and 3 byte. Depending upon 1 byte, 2 byte, 3 byte, the program counter will hold the next address of the instruction. Is clear? Then IO ports. Yesterday we have seen how many ports in 8051, ma? How many ports in 8051?
4 ports.
Yeah, very good. Super.
4,
Four,
4.
four ports. What are the 4 ports?
P0, P1,
P0,
P2,
P1, P2, P4.
P0, P1, P2,
P3.
Very good. P0, P1, P2, P3. So 4 ports are there. So the 4 ports, if I want to communicate to the ports, if I want to communicate to the external devices, I have to send my data to the ports, and from the ports only it will be sent to the external device. Data must be written into the ports registers. First it send out to the external device through ports. Similarly, if I want to receive any data from external device, so automatically my port register will receive the data. Then it will send the data to the register or some other operation. So port register is mainly to communicate with the external device. So I can communicate through only ports. So ports also, you have seen that 8-bit only all the ports are, because we were communicating only through accumulator only. We will normally in out. Did you remember the 2 instruction we have studied in 8085? So similarly here also through ports we are communicating. So port 0 also 8-bit register, port 1 is also 8-bit register, port 2 is also 8-bit register, and port 3 also 8-bit register. So here I told you all are bit addressable. Just imagine each register is in one address. So I can access through the port 0, port 1, or I can access through the address also I can access. Okay. Now, I think people please listen carefully the memory organization, because while I am telling the instructions, you have to correlate with the memory. Okay. Now, first we will recall what are the registers we have discussed. So I have discussed accumulator and B register, then program status word, then data pointer, then bank registers, program counter, stack point. I didn't touch that registers, which is interrupt register, timer register, counter register. Why means we have a separate part for timer, counter and all. At that time, I will discuss here. Okay, so 8051 architecture na, you have to explain till what I have explained today. Can you understand? It's a 16-mark question. So please explain this diagram. Can you understand? After explaining, this is the key points. Okay, today I will post this PPT in our LMS. So please kindly view on that. Okay, so this is the architecture futures, and then system clock followed by registers. So I have explained till this. You have to explain for this question. Can you understand or not? So till that 80, I think we all understand. Now you have a separate part about memory in 8051. Sometime this question may be asked in 8 marks, or sometime it may be asked in to explain about internal or external memory along with it. So you have to be prepared to at least for 8-mark question. So you have to know what is memory organization in 8051 and how we were classifying that. Okay. 8085 and 8086, what is the main difference in memory? Anyone tell ma? 8085 and 8085 and 8051, what is the main difference in memory? I told you a difference in microprocessor and microcontroller. What is the main difference? Yeah.
Internal memory and external memory is different.
Yeah, Shanmuga. It's what he's saying now. In 8051, 8085, we have only external memory, no internal memory. But 8051, we have both internal as well as external memory. Okay, so onboard memory is there. So if I want to do any specific application, I can store my memory, I can store my program, I can store my data in internal memory itself. I no need of any external memory depending on the applications. So we have an internal memory as well as external memory. Are you clear, ma? Can you understand? Now we will discuss about the internal memory. Okay, internal memory and external memory, we have both RAM and ROM. We all know RAM means what? Read and write. ROM means read only. Okay. Now we have seen the capacity. In this internal memory, we have 256 bytes and ROM is 4 KB. Okay, first, and then external memory, we have 64 KB, 64 KB. Can anyone tell how we were getting 64 KB, ma? How it is depends on what? Leave internal memory. I will explain you why it is that capacity. External memory, I'm saying 64 KB. How we are saying 64 KB?
2
Yeah,
power 8, ma'am.
2 power 8 is not there. How many address lines are there? Tell me how many address lines? How
16
many
address
address?
line.
16 address line. So 2 power 16. 2 power 16 is equal to what is my value, ma? 65,536 byte. Okay, so that's I'm saying 64 KB. Are you clear? So external memory depends upon which line, ma? Address line, not data line. Can you understand? So 2 power 16, 64 KB is my external memory capacity I can use. Now I can come with my, yeah, are you clear? Okay, now I can come with my internal memory. So internal memory, I told you, external memory we will discuss separately. Now we will focus on only internal memory. Internal memory, RAM, I'm saying 256 bytes. ROM, I'm saying 4 KB. Now we will see. Okay, so internal memory, I think you people please note it down because it's a very important thing, memory of 8051, because sometime we will use internal memory, sometime we will use external memory. You have to understand the difference between data and memory. So that's why internal memory, you have to understand well the capacity. Okay, so internal memory is 256 bytes. Actually, in the olden days, they started with 128 bytes. Some of the book specified 128 bytes, but while I'm upgrading that, it is moved on to 256 bytes. So no need of worrying on that. So 256 bytes are, we will mention only 256 bytes RAM and 4 KB ROM. Okay, now we will see. 4K ROM on chip. On chip means the memory is inside the chip. Internal memory. Can you understand or not? In my program, my microcontroller having the on chip na onboard memory I'm having. Okay, I'm saying 4K. 4K means how many locations they are allocating. 4K na 4096. So you understand this. My value is vary from 00000 to 0FFF. Okay, if you convert this FFFF, what is my value? FFF means which value, ma? Which value? Hexadecimal value. If I convert this FFFF, what is my equivalent value in decimal? 4096. That's why I am saying how much, what capacity? 4K capacity. So they are saying the ROM locations will
4K.
vary 4K. So here 2 power 12. Actually, how many address lines, ma? FFF means how many ones? For F41. Next F41. The last F41. So totally how many, ma? 12-bit address. So the internal ROM, actually
12-bit address.
12-bit address, but I'm not using this 12-bit address. Why? It is which memory, ma? It is which memory? Internal memory, not internal memory. Correct, internal memory only. But it is which memory? ROM. Okay, read only memory. So I can read the data only from the memory. I can't able to write or I can't able to do the programming. Can you understand? So the programming will not done in the ROM memory. You have to know only the capacity of the memory. Okay, we are not do any programming in ROM. Why? ROM is what, ma? I can read the memory only. Can you understand? Okay. Next, the very important memory. That's why I have specified. What is internal memory capacity, ma? ROM. So my memory will vary from what, ma? 00000 to 0FFF. So this is what is the capacity? 4 KB. 4 KB means what? How many locations? 4096 locations are there. Can you understand? 4096 locations. This is mainly used to read only. Actually, the inbuilt we have a memory, so we can't able to alter the data in this memory. Okay, we can read the data only, we cannot alter the data. Okay, the next one is RAM. Okay, it's very important memory. RAM 4 KB capacity, 4096 locations are there. That's leave it. Now RAM memory only, we will done the programming only in this RAM memory. So you have to understand about this RAM memory very well. Okay. Now RAM memory, what is the capacity of my RAM memory, ma? 256 bytes. Please listen well. 256 bytes are in RAM memory. So 256 bytes means I can vary my data from 00 to 7F. How many 7F means what is the equivalent value in decimal? 128 bytes. Then FF means totally FF means what? 256. So 00 to 7F 128 bytes. Then after 7F, what is my next number? 80. 80 to FF, how many data ma? 128. So 128 plus 128, what is the data? 256 bytes. So my memory location will vary from 00 to FF. Can you understand? So how many bit address is needed for here? Actually, internal memory, how many address lines are needed, ma?
16.
16 is, you understand well, external memory only 16 bit. Why? What is the capacity? 2 power 16, 64 KB. So don't get confused. Internal memory, how many address lines only with there?
8.
Why 8? Why? Why 8 address lines?
Because 2 power 8 is
Ah,
256.
yeah. How many locations only in internal memory? 256 locations only there. Can you understand or not? Only 256 locations are there means I can have only 8-bit address to take the memory or feed the memory, or I can transfer into the memory, or I can retrieve from the memory. So 8-bit address to access for internal memory and 16-bit address to address lines for access the external memory. Are you clear on this point, ma? Students? Are you clear? So why I am saying 8-bit address? How many locations are there? Only 256 location. So 00 to 256 means my address lines will vary from 00 to FF. So FF means what is the FF value? 1 1 1 1 for 1F, and next F and R41. So totally how many bits are there? 8-bit. So 8-bit address to access the 8-bit data in internal memory, but for external memory 16-bit address. Okay. Now, this is I have specified 128 bytes separately and another 128 bytes separately. 00 to 7F, what is the value? 128 byte. 80 to FF, again 128 locations are there. Okay. The same thing I have separated and draw, nothing that. Then, now I have segregated that 128 bytes internal memory. Okay. In 128 internal memory, 32 bytes 32 bytes is allocated for which, for what, ma? Bank register. Bank 0, bank 1, bank 2, bank 3. Each bank contains how many registers, ma? Anyone please tell?
8.
Eight. Super. 8. So 8 into 4, how many, ma? 32. So 32 bytes they are allocating simply for bank register. So my bank registers are stored where, ma? In my internal RAM. Okay. After bank, this is bit addressable area. For example, they allocated 16 bytes for bit address. Bit address in sense means I can able to communicate through the address. I can use that address to write as a program. So that is bit address area. And this is this 80 bytes for general purpose area. Okay. So this is for bit level means, for example, I told you that bit instructions are there. To set and reset, I can use this bit address area, and this is I can use as a general purpose area. I can use 30, 31, 32, 33 till 7F. I can use as my RAM location. I can store my programming here. So here you see 32 bytes for register bank, 16 bytes for bit level, and 80 bytes for general. So 80 plus 16, 96, 96 plus 32, 128 bytes. So this is my 128 bytes of memory locations. Are you clear, ma? Can you understand? So first 128 bytes I have explained. Okay. Next, this is 128 bytes. Actually, in this 128 bytes, they allocated SFR. SFR means what, ma? SFR is what? What is the full form for SFR?
Special function register.
Yeah, very good. Special function register. What is B? Tell me. What is B, ma? Now only B register.
B register.
ACC?
Accumulator.
PS, PSW?
Program status.
Program status word.
P3?
Fourth, ma'am.
Port 3. P2,
Fourth, two.
2, ma'am.
P1,
Port 1.
P0,
Port 0.
port 0. SP, SP,
Stack pointer.
Stack pointer.
DPH,
Data pointer.
DPL,
Data pointer.
higher order byte. Very good. DPL,
Data pointer.
data pointer. Super ma. Okay. So apart from that, here some more registers are there. That is SBUF and SCON. It is related to serial buffer register and serial control register. While I am explaining the serial communication, I will explain. IPIE, that is interrupt priority interrupt enable. That is I will explain about interrupts concept. Okay, then TH1, TH0, TL1, TL0. I think this T stands for timer. Okay, so this all timer control register and timer mode register. So I will explain on the timer concept. Okay, so this all we told you one point now, bit addressable register. Each register have a address. Can you understand? What is the address of B? F0. This never change. What is the accumulator address? E0. What is the address of PSW? D0. But don't think that whether you have to remember the address. No need of. You no need of remembering this address. So 82FF in that upper 128 bytes, we have allocated the some addresses for the special function registers. Okay. So they have allocated internal RAM. This is used by the programmer for storing the data. I can store my data here. I can write the programming here, and 82FFF for special function registers. See, I have separated bank 0, bank 1, bank 2, bank 3. This I have elaborately put bank 0 or not, or 1 or 2 or 3. Similarly, or each bank I am using only R0 to R7. How we will select the banks, ma? Tell me how we will select, how we will identify whether this R1 is from bank 1. How I will identify? Anyone please?
By RS0 and RS1.
Very good. RS, the 2 bits of PSW. 2 bits of BSW will decide which bank has to be selected. 0001 1011. Super. Okay. Now I'm refreshing that 32/7F I will allocate for the general purpose programming. Okay. We all know 8051 is a 8-bit data bus. If I'm writing my code, MOV means what?
Move.
Move actually. Move means here this addressing modes are there. At that time we will study about this. Here you see I'm 3A is my data, 50 is address. Why here 50? Why I put 50, ma? Why I put 50 here? Why 50?
Move address.
Yeah,
Decimal number.
it's a 50 is my address. Why? My internal RAM location have only 8-bit address line. Can you understand or not? I'm using 32/7F to write my program. 80 bytes they are allocating to write the program. 80 memory locations they are allocating to write the internal memory locations to write the program. So move 50, 3A means in the 50A address, I am storing my data 3A. Can you understand or not? Hash means hash represents MVI. Did you remember MVI? What is MVI, ma? In
Immediately.
move immediately. Very good. So here also this hash also indicates move immediately. Move immediately my 3A value to 50. So 50 is my address, 3A is my data. Can you understand or not? Why 50? It is a 8-bit address lines because internal RAM have a capacity of only 8-bit. That's why I put 50 here. So 3A is my data. So we are moving my data to the memory location. Okay. Now we finish the internal memory. RAM having what is the capacity? 256 bytes and ROM having 4 KB. Okay. Now external memory. External memory, I told you 64 KBs are there. So in external memory, they have a 2 memory, ROM as well as RAM. They have a 2 memory. ROM 64 KB. How many locations, ma? 65,536 locations are there. So my address lines will vary from 0000 to FFF. How many F's are there? 4F. 4F means what? 11111. So totally 16 ones are there. So if I want to access my external memory, definitely I need 16-bit address line. Are you clear? I need a 16-bit address line. So now again we will come to this point. I have mentioned only 60 KB, 4 KB. That we will see in the next slide. Okay. Now external memory ROM 64 KB. 64 KB means, see, my address lines vary from 0000 to FFF. So you see move C. They have one word move C. A means what?
Accumulator.
DPTR?
Data pointer.
Data pointer. Very good. So C means, the C stands for, if I want to access my program code memory, we use the word C. External ROM memory, coding memory we will say. Okay, so that is stands for move. So this again, that's we will specify. So mainly DPTR, I told you usually to access the external memory only we use the DPTR. Okay. See students, I think on the slides get changed. This is internal RAM memory only. Okay. Same thing, register bank 0, bank 1. And I told you na bit address vary from general purpose. That's only. This all in detail I have put it. I think the slide I have changed. So B address, accumulator address, PSW address, interrupt priority address. Okay. While I'm uploading, I will shift and upload. You need not to remember the address. You have to remember only the thing. So whatever you want to study, I will prepare the PPT and I will upload it. Then you can understand in detail. Okay. Now you come to this. This one diagram will specify the memory map of 8051. Memory map of 8051. Edukala ma'am. Okay. Now you just see what is my external capacity, ma? 64 KB. I told you ROM memory. Okay. And here internal I told you 128 bytes. And this 128 bytes for what, ma? SFR. Okay. So totally RAM locations are there. Okay. Now you come to the external memory. In external memory, we were saying 4 KB onboard memory we were saying now. How they are classifying now? 60 KB will be in outside and 4 KB will be inside. So EA, did you remember this EA pin, ma? Yesterday we have seen 3 pins in 8051. I told you EA pin, then PSEN pin, then ALE pin, apart from ports and supply. If EA bar, that is EA bar is that EA pin is connected to one, na, it should access the internal memory. If EA pin is connected to 0, na, this 4 KB will go to the external memory. So 4 KB is a program memory. So how they are allocating, ma? 60 KB plus 4 KB. Can you understand or not? 60 KB will be in outside and 4 KB will be in inside. So if my EA value, the pin we have seen, the EA pin, if EA is connected to VCC, automatically